All right, we're back. Sorry, keep getting interrupted. So anyhow, we're solving for n. So we're at the point now where we're going to go 72. We're going to divide it by 16, and that would be 4.5. So n would be equal to 4.5 and number 5. Okay, sorry for the interruptions. Now let's go ahead and solve for x. So the one thing that we want to know, or that we want to figure out is that, all right, so how are we going to solve for x? And then we also have to figure out the value of y. Okay, so what you should notice is that for this problem right here, this angle, which is represented by 5x plus 3, is that angle. And then the angle that has the x in it also, 7x minus 19, is this angle right here. Okay, well those two angles are going to be equal to each other because they are alternate interior angles. Okay, and we know that this shape is going to be a parallelogram, and we know that it's a parallelogram because both pairs of opposite sides are equal to each other. So that would mean that we're ensured that it's a parallelogram. So to solve for x, we would take the 7x minus 19 angle, we would set it equal to the 5x plus 3 angle, and then we would use algebra to figure out the answer for x. Subtracting 5x from each side, 2x minus 19 becomes equal to 3. Adding 19 to each side, 2x becomes equal to 32. Dividing by 2, we get x is equal to 16. So that would be what x would be in number 5. Okay, then to solve for y, what we would do is you would want to use this triangle right here, which I'm outlining in green, and we would use this triangle because y is in that triangle, and we actually know how many degrees that angle is, which is 24, and then we're going to substitute 16 in the place of x here to make this angle 5 times 16, which is 80 plus 3. So that's going to make this angle 83 degrees. And then we're going to use the theorem that says the three angles in a triangle, in the three inside angles, interior angles in a triangle, add up to 180. So adding up 24 and 83, I'll do it up here, we get 107, and then we're going to subtract 107 from 180. And that would give me my answer for y, so y is going to be 73 degrees. Okay, flipping it over, we're moving on to number 6. So the first thing we want to do, I think in number 6, would be let's go ahead and let's name the shape. So if you notice, in number 6, we have just one pair of parallel sides, as indicated by those arrows, and then we know that side B to A is the same length as side C to D, as indicated by these marks. So this shape is an isosceles trapezoid. Okay, so that means that we have a trapezoid, but it's isosceles because the two legs, B to A and C to D, are equal to each other. Okay? Alright, so now let's use that information in order to solve for x and solve for y. Alright, so if you notice, this line segment right here, which is 2x plus 1, well, that's a mid-segment. And the mid-segment property says the mid-segment, which is 2x plus 1, is equal to the sum of the two bases divided by 2. So I'm going to take this base, 2x minus 2. I'm going to add it to this bottom base, 3x minus 3. And then I'm going to divide that by 2. So I'm going to take the two bases, I'm going to add them up. Then I'm going to divide that by 2, and that's going to be equal to the length of the midsegment. Okay, that's called the midsegment property of a trapezoid. Okay, so solving this out, 2x plus 1 would be equal to, and I'm going to combine the 2x and the 3x in the numerator to make 5x. Then I'm going to combine the minus 2 and the minus 3 in the numerator to make minus 5 divided by 2. Okay, now in a previous video I had told you that if 2 divides into both of these numbers evenly, go ahead and divide. But if it doesn't divide into either number evenly, then go ahead and multiply both sides of the equation by 2. Okay, so that would make this, distributing the 2, 4x plus 2. And that would make the right side of the equation, those 2's would cancel out. So we would get 5x minus 5. Then we would solve. So I would subtract 4x's from both sides of the equation. That would cancel out the 4x's, and I would get 2 is equal to x minus 5. I would add 5 to both sides, so x is equal to 7. Or 7 is equal to x, either way. So there's my answer for x. Okay, now to find the value of a, notice that we have a 4a plus 1, which represents this base angle. And then we have a 6a minus 13 degrees, which represents this base angle. So remember, in an isosceles trapezoid, the bottom base angles are equal to each other. So to solve for a, I would take the 6a minus 13 angle, make it equal to the 4a plus 1 angle. And then I would use algebra then to solve that out. Subtracting 4a from both sides of the equation, that would give me 2a minus 13 is equal to 1. Add 13 to both sides. That would make the equation 2a is equal to 14. Then I would divide both sides by 2, so a would be equal to 7. And there's my answers for number 6. Okay? Number 7, find the sum of the measures of the interior angles for the following convex polygon, and it's a 17-gon. So to find the sum of the interior angles, we use the formula n minus 2 times 180, where n represents the number of sides, which in this case is 17. So we would go 17 minus 2, which is 15, and then we would multiply 15 times 180. And I'm using my calculator off to the side here, so don't be super impressed and think that I'm doing this in my head. The answer is 2,700 degrees. Okay, so there's number 7. Number 8, and number 8 and number 9 were the same problem if you notice. So number 8 we're going to do, but we'll skip number 9. Number 8 says find the measure of each interior angle for the following regular gon, and we have a decagon. So remember, decagon means we have 10 sides. And the formula we use to find each interior angle is we go n minus 2 times 180, which is the formula we just used in number 7, but then we divide it by n. And in this case, n is going to be 10. So we would go 10 minus 2, multiply that by 180, and then we would divide by 10. Okay, so 10 minus 2 is 8. 8 times 180 is 1,440. So we would go 1,440 divided by 10, and that answer is 144. So that would be the answer to number 8. Okay, each one, so if we have a decagon, remember if it's regular, that means all the angles are going to be the same. Every single angle would be 144 degrees. Moving on to number 10. Number 10, find the number of sides for a convex polygon whose interior angle sum is 3,060 degrees. Okay, so if you notice, we want to find the number of sides, and we know that the interior angle sum is 3,060 degrees. So to solve this, we're going to use the formula n minus 2 times 180. Now remember, that formula tells us how many degrees all the interior angles make, and that's going to be equal to 3,060. And n stands for the number of sides, which is what we're finding. Okay, so to solve this problem, I would divide both sides by 180 just right off the start to eliminate those 180s. Then my equation would become n minus 2 is equal to 17. 3,060 divided by 180 is 17. And then you would add 2 to both sides. So in number 10, this shape has 19 sides. Okay, number 11, find the number of sides for the following regular polygon given the measure of each exterior angle is 7.5 degrees. So remember, the formula that we use to figure out the number of sides is we take 360 and then we divide it by an exterior angle, which is 7.5. So to figure out how many sides this shape has, we would go 360 and we would divide it by 7.5. 360 divided by 7.5 is equal to 48. So this is a 48-sided shape. Okay, so that's how we would do number 11. All right, now the next problems, we're skipping over to number 13. And for numbers 13 through 24, it says write all, some, or no, then explain. I really am not concerned about whether or not you explain the answer. I'm just concerned if you know how to figure out if the answer is always, sometimes, or no. That would indicate that the answer is never. Okay, and then so to do that, remember what you're doing is you're going to be referring to the notes, and these are the notes that we took on October 18th. Okay, so these are the notes that are going to help us out get the answer if it's always, sometimes, or never. So remember, the way we read these notes are, if you're moving from down this diagram, the answer is sometimes. If you move up the diagram, it's always. If you move across the diagram, it's never. So notice, rectangles are squares. So that means in number 13, we start at rectangles in our diagram, then we move to squares. Rectangles to squares. We're moving down the shape. There's my arrow pointing down, so the answer is sometimes in number 13. Okay, so that would be some. Number 14, isosceles trapezoids are parallelograms. Now, isosceles trapezoids fall under the category of trapezoids. Okay, are they parallelograms? We're moving across, so that would be never. So number 14 would be no. Okay, rhombuses are quadrilaterals. The way we would read this chart is we start at rhombuses. We're going to move up the shape to quadrilaterals. Whenever you move up the shape, notice there's the arrow going up. The answer is always. So number 15 would be all. Okay, so we're just using that diagram from the notes we did on 1018. Squares are triangles. That is no, that's never. Rectangles are regular quadrilaterals. Okay, so here we have rectangles, and then we have regular quadrilaterals. So what is a regular quadrilateral? That's where you got to think, well, that's a square. So we're moving down the shape, so that would be sometimes. Okay, number 17 is sometimes. Number 18, quadrilaterals have 4 congruent angles. So remember, so now when we do that one, we only mention one shape, quadrilateral. And then we're going to answer yes or no for every shape below quadrilateral as if they have 4 congruent angles. So we're going to start here. 4 congruent angles, no. 4 congruent angles, yes. 4 congruent angles, no. 4 congruent angles in a square, yes. No in a trapezoid. Now remember, if you get some yeses and some nos, the answer is sometimes. Number 18 is sometimes. Number 19, rectangles are rhombuses. So we're going to start at rectangles. We're going to move the rhombuses. We're moving across the diagram. The answer is never. So 19 is no. Number 20, trapezoids have one pair of opposite sides parallel. So we're going to be at trapezoid, and there's no shapes to move to. Excuse me. So we're going to say yes or no. Do trapezoids have one pair of parallel sides? The answer is yes. So this would be all, or always, okay? 21, trapezoids have 2 pairs of congruent sides, okay? So here's a trapezoid. Will the top and the bottom be congruent, and will the left and the right side be congruent? Can that ever happen? The answer is no. 21 is never, or no. 22, squares are regular quadrilaterals. Okay, so here's my square way down here. So that's where I'm going to start. Where are the regular quadrilaterals at? Well, the only regular quadrilateral would be right here. So the answer is always. 22 is all. Okay, 23, trapezoids have 4 congruent sides. Never. If you have 4 congruent sides, so we're going to start here. What has 4 congruent sides? A rhombus or a square. We can't move across, so that's never. 23 is no for never. 24, parallelograms have 4 congruent angles. So let's start up here at parallelograms. 4 congruent angles, yes or no? No. Four congruent angles, yes or no? Yes. Four congruent angles in a rhombus, no. Four congruent angles in a square, yes. So we have no, yes, no, yes. Some yeses, some nos, meaning the answer is sometimes. Okay, there we go.